All right, so I think we're recording. Let's take a look at solving these absolute value inequalities. In each step, we want to get the absolute value by itself and then look at the direction of the arrow, whether it's pointing towards the absolute value or away from the absolute value, to help us know the description of the solution set. So here at number 9, I'm going to subtract 6 from each side. So I have the opposite of the absolute value of 5 minus 4x as being less than, and if I subtract 6, I believe I get a negative 37. If I multiply both sides of this inequality by a negative 1, that changes the sign, and I get the absolute value by itself. I have to change the direction of the arrow, and we have the arrow pointing away from the absolute value. So we know our solution set that the tails of the number line are going to be shaded, that the center of the number line is not going to be. So this splits into two inequalities. We call that a compound inequality because it's separated with the word or. So we have this 5 minus 4x is our expression, and we change the direction of the inequality and we change the sign of the number. And then on the second inequality, we just simply drop the absolute value. 5 minus 4x is greater than 37. So now we solve these independently and then graph them together on a number line. So I'm going to subtract 5 from each side, and I get negative 4x is less than, and if I subtract 5, what do I get? A negative 42. And now if I divide both sides by a negative 4, what is 42 divided by 4? 10.5. So it doesn't divide it. So I change the direction of the arrow, and x greater than, and both negative 42 and negative 4, the negative cancels. They're both even numbers. So I'm going to reduce my fraction to 21 over 2. Now over here, we do the same thing. We subtract 5 from each side. We have negative 4x is greater than 32. When I divide both sides by a negative 4, this time 32 divided by negative 4 is negative 8. So what do we have? Well, let's shrink this up. Our critical points are, or if you want to refer to them as endpoints or our boundaries, are negative 8 and then 21 over 2. So negative 8 is to the left of half of 21, which is 10.5, but I'm just going to keep it as 21 over 2. All right, so I'm not going to include these in my solution set because this was a strict inequality. Neither one of these arrows were underlined. So let's look at this one. Values of x that are strictly less than negative 8 are to the left of negative 8. So all of these points are in my solution set. Now let's look at this one on the left here. X greater than this 21 over 2, greater than are all these numbers that are bigger than this 21 over 2, than this 10.5. Now we want to describe this using interval notation. The left arrow is shaded. That's a negative infinity. This endpoint is hollow, so I have to use a parenthesis and not a bracket. Then since there's a gap in my graph, I have to use a union because either you're in this interval or you're in this other interval that is from 21 over 2 out to positive infinity. So here's my solution set for this absolute value inequality in problem number 9. Let's take a look at problem number 10 and see if we can't figure out what the solution set is here. All right, so the absolute value is not by itself. That's on the left, I see two terms. I want to start out by subtracting 3 from each side. So I have 7 times this absolute value of negative 6x minus 8. When I subtract 3, 101 minus 3, I believe is 98. If I divide both sides by a positive 7, I have negative 6x minus 8 is less than 98 over 7. I think that's, I don't think that divides it. 98 divided by 7. Oh, it does. 14. See, I'm not very good at mental arithmetic. I did not see that this is the number 14. Sorry about that. All right, so my arrow is pointing towards my absolute value, so the center of the number line is going to be shaded. I can write this as a compound inequality by saying negative 14 is strictly less than negative 6x minus 8, which is less than positive 14. In these compound inequalities with and, notice that the arrows are always pointing in the same direction and always pointing to the smaller value. So let's add 8 to all 3 sections here. Negative 14 plus 8 is a negative 6, which is less than negative 6x, which is less than, and 14 plus 8 that's 22. Let's divide everybody by a negative 6. So we'll have 1 here. The arrow will change directions. We'll have a 1x. The arrow will change directions. We'll have a negative value here. Both of them are even, so half of 22 is 11. Half of 6 is 3. So this is our solution, but they want us to write it in interval notation. And I find it easier to graph on a number line if I have the arrows pointing to the left, if I have the smaller number on the left and the larger number on the right. So I'm going to rewrite this as negative 11 over 3. The arrow is pointing towards the number, and it's still pointing towards the number. This arrow is pointing towards x. It's still pointing towards x. So negative 11 thirds is a little bit shy of negative 4, and positive 1 is somewhere over here. I'm going to exclude the endpoints. I'm not going to shade them in because I don't have equal signs, and I don't have the underline underneath there. It does not have equality. It is a strict inequality. So both of these remain hollow, and I just shade in the numbers that are in between there. And then I write my final answer in interval notation. So I have negative 11 thirds as the smallest value, comma 1. I use parentheses and not brackets because, like we said, the endpoints were not included in the solution set. So there's our final answer. Ask any questions as needed. Let me know if I've made any silly mistakes so that I can edit the video. But anyway, I hope this helps, and I will talk to you later. Bye.